Alright, we're gonna take another look at the Pythagorean comma and the Platonic theory of forms, the realm of forms, Platonic number, and basically in Platonic philosophy, the Pythagorean apeiron, or unlimited, was changed to mean irrational magnitude, or a logon, and this is from Philolaus. And so Philolaus created the Pythagorean comma as a philosophy. So if we look at the Wikipedia page, we will see the basic lie of the liar that covers up the noncommutativity. Now what the Pythagorean comma states is the difference between the perfect fifth and the octave, and you get this interval value which the phone is not focusing on. Let me see if I can get that to focus. 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 There we go. Now, if we go down to this part of the page right here, it says that the diminished second is the opposite of the Pythagorean comma, and so can be viewed as a descending Pythagorean comma. And if we go over to this page, this graph, it explains that the Pythagorean comma has the same width but in an opposite direction as the diminished second. So this width is the same, or so they claim, but this is actually the lie from the liar of the liar when Philolaus flipped his liar around. So we have right here in Wikipedia a straight up mathematical lie. And we can prove this by going from the Pythagorean comma page to the Pythagorean tuning page. See, we were just on Pythagorean comma. Now we go to Pythagorean tuning. And what do we find is that the diminished second and the Pythagorean comma are going in the opposite directions as ratios, and therefore there's no way that the geometric width as a line, as a magnitude, can be the same, because obviously when you invert these number ratios, which is the inversion of the octave and the perfect fifths, then you get a different value. So in this case you get about 0.98, and in this case you get a little bit over the value of 1. So therefore there's absolutely no way that the Pythagorean comma and the diminished second are the same width, but with an opposite direction, as is claimed right here on this Pythagorean. So what happened is that the the tuning is clearly based on noncommutativity, which isn't discussed, of course. But all you have to do is look at the ratios. And so you have, again, the perfect fourth right here derived from the perfect fifth as an undertone, or 2/3. That has to be then doubled back as 4/3. So then the perfect fifth, these are both perfect fifths, but one of them is C to G as overtone, and this is C to F as an undertone. But of course that's not discussed at all. So instead we're told that the unison in the Pythagorean scale, the 1-1, is actually the perfect fifth as an inherent squaring, or 3 to the 0, 2 to the 0 as 1. But in fact that's not true, because Andrew Barker, in his discussion of Boethius is mentioned in the beginning right here. Boethius right there. Boethius. So he was the first to discuss Philolaus. And as Andrew Barker, the academic professor, documents, Boethius documented Philolaus, stating that the value 1 is actually the Pythagorean comma, but as the inversion. So you're dividing it back into the octave. And so when you do